Pre-statistics. Using exponential functions to model data. Part 4. Lesson objective. Make estimates and predictions by using an exponential model. And in this video, we will use the graphing calculator regression feature for exponential functions. Example 8. The table on the right gives the year and the population in millions of California. Let T be the year since 1890 and answer the following. Number 1. Create a linear model for the data set. Round to 3 decimal places. Number 2. Create a exponential model for the data set. Number 3. Which model fits the data better? Explain. Number 4. Using the best model, predict the population of California in the years 1985 and 2015. Are these values an interpolation or an extrapolation? Number 5. When will the population reach 100 million? Number 6. The population rises blank % per year. Solution. To create a linear model for the data set, we put the value of t in list 1. In list 2, we put the population. We hit second y equals for stat plot, hit zoom stat, and graph. Next, we hit stat, calculate, number 4 for linear regression. And here we have the values for A, which is our slope, and the values for B, which is the y-intercept. And we see that r squared is 0.91. Rounding to 3 decimal places, we have the equation 0.286 times x minus 2.718. Putting that in our y equals and graphing it with the data set, we see this straight line is somewhat modeling the data well. Let's try our exponential model. So we go to calculate, 0 for exponential regression. Here we have the initial values for A and the base, and r squared is 0.989. So according to r squared, this model is doing better than the linear. Rounding 3 decimal places and typing in the values of A, B, and y1, we see that the exponential model is doing a better job than the linear. Number 3, which model fits the data better? Well, that would be the exponential model, both by the value of r squared, 0.989 versus 0.913, and also visually. This exponential curve is doing a better job than this straight line. Using the exponential model to predict years 1985 and 2015, we use the exponential equation raised to the 95th power for 1985, and we get 28.9, and for 2015 t is 125, and we have an output of 76.58. We could also use our table function. If we hit second and window for table set, change the independent to ask, we can type in 95 for x and 125, and we get the corresponding outputs. The value of 28.91 as an interpolation, as the independent value of 95 is in the domain. The value of 76.57 is an extrapolation, as the value of 125 is outside the domain of the independent values. Number 5. When will the population reach 100 million? Well, if we go back to the table, we tell it to start at 125. and we follow the table until we see an output close to 100. So according to the model, in the year about 2023, that's when t is 133, the estimated population is about 100 million. Number 6, the population rises about 3.3% per year. Because our base was 1.033, and if we subtract that from 1, we get 0.033, which is about 3.3%. Now, according to this website, the population in 2013 for California was about 38 million. So our model overpredicted the population. And again, according to this, the percent of increase is about 2.1%, where our model predicted 3.3%. So according to this website, in about the year 2020, the population is expected to reach about 41 million people. So whenever we extrapolate the data, our predictions can be way off. Let's summarize. We talked about a function where you put an input and it has one and only one output. We looked at linear functions, and that can be written as y equals mx plus b, or we could write in function notation as L of x equals mx plus b. M is your slope, b is your y-intercept. Next, we looked at quadratic functions, and quadratic functions can be written in the form q of x equals ax squared plus bx plus c. A cannot be equal to 0. If the parabola opens upward, a is greater than 0. If it opens downward, a is less than 0. If the parabola opens upward, it has a minimum point. If it opens downward, it has a maximum point. Next, we looked at exponential functions, and that can be written as e of x equals a times b to the x power. A cannot equal 0, b has to be a positive number, and it can't equal 1. If it's exponential decay, a is positive and b is in between 0 and 1. If it's a growth, a is positive and b is greater than 1. Thanks for watching.